The force exerted by the jet on an inclined plate lets the jet coming out from the nozzle strikes on an inclined plate. So as we have already said, the name itself implies that it's an inclined plate. So it should have some inclination. That is, inclination means should have some angle. So that angle you are taking from the reference as an horizontal surface. So from the horizontal plane you are taking that data, so that here horizontal will be your velocity along the flow, that is v of x or f of x. So in this direction you are taking this as your reference, you are taking theta or the angle of the plate, and you are saying that the plate is inclined at an angle of some theta. Okay, so v is the velocity of the jet in the x direction, that is represented in the figure. Then theta is the angle of the jet and the plate. So theta is the angle between the jet and the plate. So A is the area of the cross section. We have already said that diameter should be taken in this area. Next, the mass of the water per second strikes the water. That is nothing but rho AV. We have already made a discussion on it. Now see, in before case, there is only in the x direction and y direction. See, in the before case, there is only x direction and y direction. There are no other components like uh, f of what you say in the uh, mm, like f of n, like force in the n direction. So here the thing is that finally you have to find the forces in the x direction and y direction. If the plate is smooth and it is assumed to be there is no loss of energy due to impact of jets, then the jet will move over the plate after striking with a velocity equal to the initial velocity. See, these are the assumptions that we should make, that the plate is very smooth and there are no impact losses. If the plate is not, if generally the plates are not smooth and the impact losses will be there, but we are making assumption that the plate is very smooth and the impact losses are not there. So that means that the velocity at which the fluid is getting out of the nozzle, the same velocity you will find along the plate. If the roughness and the impact loss are considered, the velocity along the plate will be less than the velocity of the jet from the nozzle. So after that you will find the f of n, which is the force normal to the plate, okay, or in the n direction. Okay, this is the f of n, that is normal to the plate. Then generally for our whatever the forces, it is the ratio of momentum. So mass of the jet striker per second is in the after, and the initial velocity before striking in the n direction, and the final velocity of the jet after striking in the n direction. See, in the n direction you have to consider, so before striking means v will not be before striking, but you have to take the normal component. So if this is the velocity and this is the theta, this will be your 90 minus theta. Okay, this will be your 90 minus theta, so this will become your v sin theta. Okay, in that case rho ab will be mass jet strike per second, v sin theta will be your velocity component in that direction, and after striking there is no movement in this direction. Okay, there is no movement of jet in this direction, so after striking the velocity will become 0. So you will left with rho a, you multiply with these two velocities, and rho a v square sin theta. This is the force exerted by the jet on an inclined plate in the n direction. You have to remember that. Similarly, this is for the n direction. Similarly, you will find for in the x direction and y direction, that is this component. If you are going to find the f of x, and this is your f of n, which we have already calculated, then f of x will become f of n cos 90 minus theta. Okay, you see here f of n cos 90 minus theta. Here f of n cos 90 minus theta, cos 90 minus theta is nothing but sin theta, so it will become f of n sin theta. F of n you have already calculated rho a v square sin theta, that is rho a v square sin theta into sin theta. So it will become rho a v square sin theta into sin theta is sin square theta. So f of force in the x direction will become rho a v square sin square theta. Similarly, in the f of y, component of f of n perpendicular to the flow, that is in this direction. Okay. Now this f of n sin 90, it will become f of n sin 90 minus theta. That is, consider this is this. Here, if you draw a line here, you can find that f of y. We have already discussed the how to get these angles, and this is the, or this will be your opposite side, and for opposite side it will become sine. So f of n sin 90 minus theta. Sin 90 minus theta is nothing but cos theta, so it will become f of n cos theta. If you substitute f of n value that we have already extracted, that rho a v square sin theta into cos theta. So force in the y direction will become rho a v square sin theta cos theta for the inclined plate. Okay, you have to find that these forces in that direction. You should be very careful while taking the sin theta and cos theta. That's all that you have to remember here.